Welcome to Haltech Elite NSP Training Part 35. In this training tutorial, we're going to focus on using our long-term fuel trim correction in our closed-loop fuel correction that we've already discussed. This is going to be another layer that we can implement. This is something that you might want to utilize in your tuning strategy, so we're going to break down how it works and how to utilize it properly. Without further wait, let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at working with our long-term fuel trim within our Haltech Elite systems. Our long-term fuel trim is going to be building off and basing off the closed-loop fuel correction and specifically our short-term fuel trim adjustments. Now, we've talked about this pretty extensively, so you should understand how the closed-loop correction works and what the short-term fuel trim here represents. The long-term fuel trim is going to look at the behavior, the learned behavior of what the short-term trim is doing here at different ranges of our operation in our table here. So depending on where we're at within our table, whether we're at idle, cruise conditions, or full throttle conditions, the short-term trim is going to make its adjustment. The long-term trim is going to watch that behavior and then absorb that to a base table. So the short-term fuel trim has to do less work. So it's going to have minimal adjustments to make. We can use the long-term fuel trim and the control of the long-term fuel trim to help us dial in our main fuel table, main VE table, whatever airflow or fuel strategy you're trying to deal with here in the Haltech. It can actually shape and dial in your table for you. So we looked at using the short-term fuel trim in order to make our changes and kind of dial things in pretty specifically in the last tutorial. If you use the long-term fuel trim, you can allow the engine to run. You don't need to essentially Hawkeye your short-term fuel trim. You can allow the Haltech to actually learn this to a table that'll apply a correction, and then you can actually transfer that correction to the base table in terms of a percentage adjustment. So you can fix an area of the table or areas of the table that are off. Now, in my opinion, this creates a lot of kind of peaks and valleys in the table and makes the table very unsmooth. If we look at our three-dimensional graphical plot of this table, it's very smooth right here. We don't find any kind of peaks or dips in the table, and we'll find that that's what we'd like to see after we dial things in. So long-term fuel trim can kind of upset that, which then requires us to come in and do some cleanup by hand using our interpolation function, which we can discuss here in a little bit. But the long-term fuel trim is a solid option if you don't have a chassis dyno or an area you can steady state drive your vehicle in safely. So if you're driving for 5, 10, 15 minutes and you don't have that chassis dyno where you have a controlled environment and you can't constantly look down at your laptop of what the short-term adjustment is doing, the long-term is a valid way to calibrate and work within your strategy for dialing your fueling in. So let's discuss exactly how this is going to work. I'm just going to recap real quickly on our closed loop operation, just so we have that just as a basis moving forward into how the long-term fuel trim works, and then we'll talk about all the specifics with the long-term. It's actually pretty straightforward to deal with and to implement, but again, we want to be cover all the specifics, all the details that we need to know. So in our closed loop fuel correction, again, we know we have our short-term fuel trim. The short-term fuel trim is offsetting our base pulse width, either coming from the fueling values from our table here, if we have injection time based or fuel flow rate based strategy selected, or if we're in mass airflow or volumetric efficiency, VE based airflow, air mass modeling, it's going to increase the pulse width that's calculated or programmed in our table here. So this is going to be an offset to our pulse width, and it bases that correction and this adjustment in the percentage of correction. It takes a look at the actual wideband reading here, compares it to your target table, and then it calculates a percentage of error. The percentage of error is what drives our proportional, integral, and derivative gains. If we jump in here to our lambda tuning, our gain table here, this is allowing it to look at that error, and then we can see what the proportional, integral, and derivative percentage contribution to the short-term fuel trim is doing. Now, we don't typically use a derivative. We see the derivative 0. I don't even have the table in here. We know that the higher the value here, the more aggressive it's going to make its adjustments in that correction. We definitely have a sweet spot for this. We don't want to be too high of a value, causing really, really aggressive, large jumps in the short-term correction that can create erratic operation and erratic fueling to the engine. So we've talked about how we deal with programming the values in here, but we should understand where the short-term fuel trim comes from and how it's actually calculated and how to implement it into our fuel delivery. So we've briefly touched on that. Again, we have a separate tutorial, previous tutorial that covered all of those details. Let's now talk about how the long-term fuel trim actually works. So what I'm going to do is jump over to main here and then jump into my navigation tree. If we go here under fuel tuning and then we move down here to O2 control, we have all the details in order to enable our closed loop fuel correction, in order to enable that short-term correction. So we can run our closed loop operation in just short-term only and never use our long-term, which if we...
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.